In this video, I'm going to show you how you can use PRoTECT to find a barrier certificate for a discrete deterministic system. The first thing you want to do is choose the system description for discrete and deterministic. Then we can set the dimensions using dim. The maximum degree of our barrier certificate that we're trying to find we can set using the max b degree. L degree is an optional parameter for the degree of our Lagrangian multipliers. By default, it's set to the same as dim. We then can describe the state space regions by choosing the lower bounds of each of the states and listing them using a comma as to separate. Then we describe the initial region xi in the same way. The avoid region xu can then be described also in the same way. If we want to add more avoid regions, we can simply click the button Add Avoid Region on the left-hand side of the screen. For the DC Motor example, we then add the following dynamics, which should be written in a format that SymPy from Python can understand. This uses stars or asterisks for multiplication and double star when you're considering an exponent. As well as manually writing in all of these descriptions, it's also possible to import pre-defined configuration files or to export your description to a JSON file in the same manner. The terms lambda and gamma for our level sets are optional, but if you wish, you can choose a value to go in here. You can also select between two types of solver, either MOSEC, which requires a license, or CVX opt. Parallelization is optional. If you wish to use it, it will use the maximum b degree and choose all even values below this and run them in parallel to try and find a solution as fast as possible. Equally, you can run without parallelization, and this will simply run exactly the b degree that you have selected. If you're happy with the parameters you've chosen, then you can just click the button Find Barrier, and this will try and find a barrier certificate which solves the safety specification for the problem you're considering. You can see the barrier is output, the gamma and the lambda level sets are also output, and this is the solution. Thanks for listening, and I'll see you in the next video.